was with sales and marketing at Osmotics. Before that was bought by GE, and he's got a Bachelor of Science in Mechanical Engineering from the University of Wisconsin. So without further ado, I'll hand it over to Craig.
Thank you, Todd. Good morning. I'm going to take the next 8 to 10 minutes here to talk a little bit about MIOX Corporation and where we're working in the oil and gas field. MIOX is a venture-backed company. We've been around for about 12 years. The technology was originally developed in the Los Alamos labs in Albuquerque, New Mexico, where we are still based. MIOX fundamentally is an electrolysis company. If you're familiar with the process, it's the same process that's used to make bulk bleach in liquid form. Simply a mixture of salt, water, and electricity, and you can produce a form of sodium hypochlorite. That's what makes MIOX the same. What makes MIOX different, and this actually goes back to the original founding of the company, is that we actually have 2 different forms of output from our electrolysis process. The top one here, traditional sodium hypochlorite, would be what you buy at Walmart for washing your laundry, or what a municipality would be delivering in bulk form for water disinfection. The innovation of MIOX really stresses around the second chemistry, the second output we produce, which is a mixed oxidant. So this is using that same electrolysis process with sodium chloride as your input, electricity, and what we've been able to do is modify the electrolytic cell, both the coatings we use on the cell as well as how we put power across the cell, to produce a second oxidant. And so the mixed oxidant is a combination of both sodium hypochlorite with a small percentage of hydrogen peroxide. And those 2 acting together actually will perform different than chlorine. Primarily what we found originally was efficacy. So if we were to measure cryptosporidium, for example, a relatively chlorine-tolerant organic material, chlorine has a very low CT and a very low log removal of crypto, whereas the mixed oxidant has performed time and time again to perform better. The other ability we have besides the efficacy is customization. And so if we look at the mixed oxidant, we can actually do customized applications for that. And that's primarily what I'll talk today in the oil and gas segment, where we found some interesting applications for that mixed oxidant chemistry. Some new developments we're working on now, an activated quaternary hypo product. If you're familiar with non-oxidizing biocides, quaternary compounds are typically the base material of those disinfectants, and we're looking at some customization in that area as well. MIOX is a technology company. We do not go to market ourselves. We actually go to market through various partners in various segments. We do cover a number of verticals. Today I'll talk just about the oil and gas vertical, but we also sell into the food and beverage market, the electronics market, lots of different applications and areas where people are looking at either specialty disinfection or to facilitate water reuse, for example, in the electronics section. So if we focus a little bit on upstream segment of oil and gas, there's actually a number of different areas where MIOX potentially could be used and has been piloted. We're seeing the drive in the oil and gas segment upstream in 2 areas primarily. The first area of interest we got was around the fracking that happens in the U.S., and there was a lot of public concern early on what fluids were being used in the frac fluid. So those of you that are familiar with the industry, there's now a disclosure website called Frac Focus, where the companies are starting to put more of the chemicals out that they use, but invariably they knew that they needed a safer, more ecologically friendly disinfectant. As they disclosed more of the chemicals they used, the public would demand that they used safer chemicals. And so we got a lot of pull from the oil and gas industry because of our municipal background. They wanted to see if they could use that same disinfectant that's used in pools and drinking water in the oil and gas segment. So really this was our first application, frac fluid. And looking at an alternative biocide where today they might use a glutaraldehyde compound or a quaternary compound that they were concerned about disclosing to the public, they could disclose that they were using a MIOX product, which was the same thing that their children swim in at their swim school. And so they felt that there'd be a lot of pull for that. Now, since that time, we've been doing that application. We found a couple others on the recycle side. So as we bring water back out, the frac flowback water that will go back into the pits, we're finding more and more customers needing to clean up that pit as they reuse that water. It's getting more expensive to discharge, getting more expensive to treat for surface disinfection, so that if they could reuse that water, that's another potential here on the frac flowback side. And now just recently we started to get pulled into some applications for enhanced oil recovery. So enhanced oil recovery, you're putting some fluid down around the oil well to try and get that next 20–30% production. And very often in enhanced oil recovery, your flood water, you want to do corrosion control and biocontrol. And in this segment, the driver isn't so much a safe alternative, but a lower cost alternative. So if you're at an injection site and using a quaternary blend from a proprietary chemical supplier, it is much more cost effective to produce salt, to produce a disinfectant from just salt on that same site. We're also seeing some applications in the downstream side of oil and gas. So in the refining process, almost all refiners have cooling towers. This is another area we've seen a lot of success with the mixed oxidant chemistry replacing a biocide program. So if you're running a cooling tower at a refinery, you might be using bromine, chlorine, and even proprietary algicides. And we found great success. This is an example of a tower in Puerto Rico, and you can see the dramatic before and after pictures where the mixed oxidant chemistry really cleaned up the tower. The technology can be put into the field in various forms and form factors. This is a generator here. That unit's about a 10 to 20 kilo per day generator. And then we can put the units also in trailer mounted units for portable and temporary use. So you could do a pit treatment at a flowback well or a flowback pond. You could also do a one-time treatment for injection water. So we're seeing the big drivers in the oil and gas sector, specifically, as I mentioned, around finding a disinfectant that's more easily disclosed to the public and that would be more accepting to the public. We would be a comparable technology to UV and ozone. Those are the other two comparables in that segment, in that kind of chemical-free green space. And then in the enhanced oil side of oil and gas applications, we're seeing the big drive just on cost. Millions and millions of barrels of water are put in for injection every day, and anything they can do to lower the cost of that injection water treatment is a benefit to them. We often see this as also termed chemical-free, which we're a little reluctant to use because we obviously understand we're making a chemical, but that the market likes to look at those chemical-free innovative technologies, and so we do fall into that space. If you have any questions later, Charles Mowry and I are both here representing MIOX and be happy to talk to you. Thank you.
Thanks very much, Craig.